Hello YouTube, welcome back. So, trying something new for this series of videos, where I'm actually going to introduce the project beforehand and just so that you can see what's going on and you have a bit of an explanation beforehand of what we're doing. What I've noticed in my videos normally is I'll just dive straight into a project, and the only time you'll find out that I'm going to do something is when I'm actually doing it. So I feel I'd make a introductory video where I just describe what I'm making and the techniques which I'm going to be using, because I quite like my videos and my series that I do. I quite like them to be educational. My main aim is to make them as clear as possible, so if anybody wants to have a go they can just go straight to it rather than having to faff around trying to find their own information. Though by all means go and do your own digging before starting on a project or attempting one of the projects that I show in my videos. So without much further ado, this video series we are going to be making a bayonet for a Brown Bess. So the Brown Bess itself was the standard musket of the British Army from the 1720s to almost up to the 1840s. Now it was a flintlock musket, built in 75 caliber, but shooting 69 caliber balls for practical reasons, because of the build-up of fouling down your barrel from shooting black powder. Means that you can just, with a 68 caliber ball, you can just drop that down the barrel because you've got plenty of space. Doesn't make it particularly accurate. It doesn't need to be, because you're going to be shooting at 100 yards, 50 yards, and there's going to be a bunch of other blokes left and right of you as well. So if you don't hit, one of you will. And yeah, so like I say, they were used up until the 1830s, 1840s almost. It wasn't actually replaced until I think 1841. There was a fire at the Tower of London, and 250,000 Brown Besses went up the chimney. So at that stage, it was decided to design a whole new musket from scratch rather than converting all these old flintlocks to percussion, which was in its early stages at that point. So they did remain in service for quite a while. I've seen a report of a Brown Bess flintlock being used at the Battle of Shiloh in the American Civil War, so that's probably some bloke's granddads or great-granddads that he brought back from the Civil War, from the War of Independence, and gave to his grandson and said, "Here lad, go shoot somebody with that." Yeah, so the name Brown Bess itself, nobody really knows where it comes from, I don't think. Back in the 1700s, Brown Bess was slang for a harlot, which for those of you who don't know what a harlot is, it's a lady of negotiable virtue. Yeah, so Brown Bess. So there were several patterns of Brown Bess. There was the land pattern, the short land pattern, the Brown Bess carbine, the new land pattern, the new carbine. All sorts, because they were used for so long. There were different variants, and same with the bayonets. Now, there's actually very little recorded about the bayonets that go with these muskets. So when I decided to actually make one of these bayonets, it was quite hard to find the information. So in order to make my life a little bit easier making this, I have produced a CAD model. So this CAD model I can then used to produce blueprints, so in that respect it is quite useful, and this is something that I'm doing increasingly as I'm making more axes and reproductions of historical items. So with regards to this bayonet, the construction of these according to the metallurgical report, the blade itself, which is about 16 inches long, and the round section coming off the blade is actually a homogeneous high carbon steel, so think along the lines of EN9 or similar. Now it's quite interesting that it is homogeneous, because most steel back in the early to late 1700s would have been blister steel, which is basically carburized wrought iron. So the CAD drawing here shows the blade as a triangular section, which is a nice sturdy shape. Now, some of these were hollow ground, some of them were triangular, some of them were fluted. This one will actually have some fluting towards the end, I think from about 2/3 of the blade down. The one that I'm reproducing is actually fluted. I just haven't put this in the CAD because it's hard work and I'm lazy. So here's an image of a original first model Brown Bess Bayonet culled off the internet. You can see the fluting on the blade. Now, to create this fluting, we are going to create a double fuller like this. And you can see the ends spread out slightly, and that's to create the transition between the triangular section of the blade and the fluting. Which isn't very clear in this image, but it does spread out. So we're going to be using a piece of handrail, which is D section, and that is because I'm going to be doing this under the power hammer. So whatever the angle, because of the rounded section, the power hammer will be intersecting the tool at a right angle. Obviously the handrail is going to be the top of the tool. And for the fullers, we're going to be using 12mm round bar, and this will be cut to the width of the handrail, which is 50mm. And as you saw in the pictures before, we're going to grind this to shape. And when I come to welding the two bits of round bar onto the handrail, we're going to be putting a wedge between them to create that gap. So to start with, I am going to forge a flat on the underside of this round bar, and that is so that it sits nicely on the underside of the handrail section, and that will make it a bit easier to position and tack before welding. So just put a flat on the underside, then straighten it with a hide mallet or a wooden mallet, whatever, depending on what you've got. If you're careful, you can do this with a regular hammer as well. And then I will mark off 30mm from each end, and that is the length I will grind. So I'll do this under the linisher. Now you could forge this, but I just found it easier to grind it. As you can see, I can get quite a nice regular shape here. And again, we're grinding it for the transition between the triangular section and the fluted section of the blade. So here you can see they've been cut down to size. Now the width of the handrail, as I said, is 50mm, so we got just 20mm of the actual original round section, but that's all we need on there. And I'm using a 3mm spacer. Now you could potentially go a bit narrower, but there's going to be a bit of grinding done to this, so 3mm I think is perfectly adequate. So I then tacked the round bar to the handrail and then went for a full side weld. And then stuck a handle on it, which gives me the fullering tool. Now I did a bit of a test on the power hammer, and as you can see it works quite well. This is just a rough test just to try out the tool and see how to use it, and that worked quite well. So the second tool we're going to be making is for welding up the eye tube. So the fixing lug itself is actually wrought iron, and the blade is actually scarf welded or faggot welded to this wrought iron tube. If we zoom in on this, you'll see that there is a cutout, and that is for the fixing lug to fit to the bayonet lug. So you can see the shape of that. I'll just spin it around a little bit more. Beauty of CAD over traditional drawings. So you can see the shape of that. It will literally slide over the sight of the gun and then lock into place. Later on, further on in the development of these bayonets, some of them had a spring that would lock it into place. Some of them also had a tightening clamp, but I think that was later on. in the history of bayonets that was developed. And you can see that the upset collar at the back here has a notch cut into it, and then it has been closed up at the top. Now that would be forge welded. Now I'll show you some photographs of an original one, and you can see the weld quite clearly on there. So in order to weld this tube up, because it will be made from flat stock and then rolled together, a little bit like a gun barrel, I need a tool to set the weld easily. So I take a piece of 20mm round bar and I will just forge down the end of that bar ever so slightly, so I'm going through the whole octagon, 16 faceagon, and then rounded. And that is just to narrow down the end of the bar so that it fits in the Pritchell hole on my flat-faced anvil, like so, because it is just ever so slightly under 20mm. And then what I will do is I will heat up the other end of the bar and I will actually forge that to a half round. Now ideally I'd do this under the power hammer, but I don't actually have a rounded bottom swage of the correct section to do that on the power hammer, so hardy hole and hand hammer it is. So obviously as you're doing that, keep it straight, because if it starts flipping off to one side, you will struggle to straighten it afterwards. And then I just went over to the linisher and smoothed off those faces, which gives you something like this. So you can see that's a half round, and the reason I'm doing it half round is so that when I'm welding up the tube it doesn't stick on the tool. So then take a localized heat just below the half round section and start bending that. And you want it to be about 90 degrees. Like so. Then you can use your hardy to get it the rest of the way. I could have bent the whole thing in the hardy if I'd thought straight, but hitting it with a hammer seemed like a good idea at the time. So next I will take this massive nut and I will actually, using a gravity clamp, I will tack it into place on the anvil. Now the gravity clamp is basically just a heavy weight which stops the tacks from shifting the nut out of position. Now I'm not welding the whole thing on the anvil because I don't really want to get any spatter on the anvil. Yeah. So we'll then head over to my proper welding station and just run some beads of weld around that nut. Now the tacks are to stop the beads of weld from distorting the position of the nut out of true, which tends to happen quite a lot when you're welding if you're not careful. So the tacks will just prevent that from happening. And there we have the tool for welding up the fixing tube on the bayonet. So these are the two tools I needed to make. I figured I'd show how to make them, along with a bad print off of the blueprint. So next week we will actually start on the blade proper, and then the following week we will make the tube, and there'll probably be a fourth episode of clean up and heat treat as well. So thanks very much for watching. Please like and subscribe. If you enjoy these videos and the projects they contain, please consider donating on Patreon. Here is my current list of wonderful Patreon donors. Thanks a lot guys, it's much appreciated. Every penny helps out making these videos. And I will see you all next week for the next episode. Bye!